Hi everyone, we're getting to our next topic in our work, power, and energy unit. This is work done by variable force, and really it's calculating work using force versus displacement graphs. For those of you who took first semester physics, this is a lot like finding displacement from a velocity versus time graph. Okay, we're going to find, notice it says, let's see, consider the force versus displacement graph. Calculate the work done by a force that is 5 newtons that is applied for 4 meters. So remember, right, when we talk about work, you should know that is force times distance or displacement, right? And we see that the force is 5 newtons. We see the displacement is 4 meters, which gives us a work of 20 joules, okay? Then it says find the area of the graph to the right. What you can see is the area is this rectangle, right? And remember, when we talk about the area of a rectangle, you should remember that the area of the rectangle is always base times height. And so what we can see is our base, right, is here. That is 4 meters, right? Just a reminder that you have to make sure to look at the units, times our height, which is this. It says 5 newtons, which is equal to 20 joules. Haha. How do the area compare to the calculated work? They are the same. So you can figure out or calculate the work using the area under the line, okay? Using the area under line. Now that wasn't variable work, that was actually constant force, okay? So this is variable force. Remember, there's 2 different area equations. There's one for a rectangle and there's one for a triangle. And then just remember that there is a total right where you just add up the sums. So here we go. Example number 1, positive variable force, only one area. You can see here, right, that this is going to be, 7 up to about, let's see, 350. Okay. So when I do this, I'm just going to use pink, right? The area is a triangle. I'm just going to abbreviate with a T, is equal to 1/2 base times height. Now, I'm going to have you guys show it, hopefully this way, because a lot of you sometimes have trouble, I don't know, kind of figuring out where the base is. So I think it's going to be easiest to do it with this technique. 1/2, my base is going to be 7, right? And I'm going to work all the way back. So I'm going to say that my base is 7. Notice this is centimeters minus 0 centimeters. Okay, so you're actually going to write in what the 2 values are for your graph. Then your height is going to be 350, right, down to 0 as well. So I'm going to write 350 newtons minus 0 newtons. Now for this one, it's really easy because both of those are 0, but you'll see what I mean coming up. This would be 1/2 7 centimeters times 350 newtons, and that ends up being 1,225. Now be careful, this is Newton times centimeters, right? That's not joules because our unit is in centimeters. If we wanted to convert to joules, all we would have to do is move our decimal and divide by 100, right? There's 100 centimeters in a meter, which means this would be 12 1.25 joules. Remember, joules are Newton times meters, not newtons times centimeters. Okay? Second example, two areas, positive constant force and variable force. So what you'll see here, right, is there is this rectangle. Oh, let's use our highlighter because it's going to fill this in faster. Our rectangle is here, right, this part here. And then we have a triangle over here. Okay, so there's two different parts. I'm going to have to do that the area total is equal to the area of the rectangle plus the area of the triangle. Okay, so let's figure out each of those first. The area of the rectangle is equal to base times height. Base times height then is going to be, let's see here, 20 to 0. So this is 20 minus 0. Oh, wait, hold on. Let me put my units in. 20 meters minus 0 meters. And my height is here 100, right, down to 0. So 100 newtons minus 0 newtons. This gives me 20 meters times 100 newtons. So that is 2,000 joules. Then I'm going to figure out the area of my triangle, which is 1/2 base times height. Now this is where this technique will help, right? My base is 30 down to 20. So that's what I'm going to write. 30 meters minus 20 meters. I know a lot of you can do that in your head, and that's totally fine. But please do this technique just so that you know, right, what you're doing is correct. Then this is 100 newtons minus 0 newtons. So this is 1/2 times 10 meters times 100 newtons, which ends up being 500 joules. Then we just have to add these up, right? The total is equal to 2,000 joules from my rectangle plus 500 joules from my triangle. And so this is 2,500 or 2,500 joules as my total.